Hey guys, I hope you're doing well. So today we're going to talk about Emacs-Lisp once again, and this time we'll be working with lists and also with loops. So the two subjects intertwine somewhat, so I figured it'd be interesting to tackle the two of them in sequence, and that's what I'll be doing. So let's begin with loops and get right into it. So essentially loops are again control sequences, just like in any other programming language. And in fact, what's interesting about Lisp is that the control sequences are defined as functions. So instead of memorizing the syntax for a while loop, just like you do in, for example, C, you actually just need to know the name of the function because it's just a function call, exactly like all the rest of Lisp. So in that sense, it's much easier to work with. And this is the format again for the simplest loop, which is the while loop. And the while loop, as the name implies, is just going to execute whatever you put inside this block as long as the test is true. So you put in a conditional here or whatever. It must be something that's either true, so non-nil or nil. And whenever the test returns nil, it's going to leave the while. So again, very simple stuff. And as an example, we can use this in order to make a little function like this. So this function is going to print all the numbers starting from the number here. This is given as argument until the number 10. So I implemented this with a while loop, and the while is essentially checking whether or not the number is smaller than 11, because 10 is the last number for which this is going to be true. So if this is the case, if the number is smaller than 11, then I execute this block here. And this block essentially prints the number. So this message format with the %d is the C format for making an integer placeholder. This is an integer. And once I print it, I'm going to change the number. So I'm going to increment it. I'm going to add it to 1. Now I'm going to actually open a messages buffer here on the side. So let me do just that. And let's clear the screen and try. Essentially, first things first, we'll execute this in order to get the function definition. So now that I define the function, I can actually call it in my code. And I'll do this by defining a variable. So variable is equal to 1. And I'll print up to 10 starting from 1. So if I execute this block, notice I get this printed. So 1, 2, 3 up until 10. And obviously if I change this, so if this is 3, I execute it again and I'm starting from 3. Simple stuff. Now additionally, just give me 1 second. Okay. Now additionally, I can try, for example, printing a range, and this is a similar logic, again, same function using the while. This is a new function which is print range mn, and this is going to, as the name implies, again, take a number m, take a number n, and then it's going to print all the values in between. So starting from m all the way until n minus 1. And I can implement it in the same way. So I essentially changed the logic up here, and instead of 11 being a fixed number, I'm now giving it as an argument as well. So the logic is the same. I'll just run this and execute this code. So for example, this is going to print the numbers between 10 and 15, except 15. Now, I also have what is called dotimes, and this is what's the most similar with the for loop. So if you think of other programming languages, you have a for loop, which essentially executes stuff a fixed amount of time, so a count amount of time in this case. And the basic definition looks something like this. So you have dotimes followed by var. This is actually a symbol, and count is a number. So this is an integer. And inside of the expression, you're essentially going to replace var with an iterator going from 0 all the way to count minus 1. So it's as if var was the I in your C or C++ code, for example, or Python or whatever it is that you use. If I can use this, for example, to print values from 0 until n minus 1. And this is what this function looks like. So I take in an argument, a number n, and then I'm using the dotimes iterator is the name of the symbol, and n is the amount of times I'm going to iterate. And if I execute this, I get the function definition. And if I run this, for example, print n times 55, I'm going to print the numbers between 0 and 54. That's what it looks like. Now, again, loops are not very challenging, but what's interesting is that you can use them together with lists to get some very interesting behavior. Now, lists, they are declared by using the quotation mark just before parentheses. So they kind of work like an escape sequence, because usually opening parentheses states the opening of a function. But in this case, if you put the quotation mark in front, you're escaping it and turning it into a list. So here I am defining a list called myList, which contains the item A, B, C, and D. So 4 elements. I'm evaluating this, and some important functions for list manipulation. So these functions kind of, the names anyway, relate to how Lisp machines were implemented back in the day. So for example, CAR stands for contents of the address register. This is the first element of every list. And conversely, CUDR or CDR, I really don't know how you pronounce this. I don't even know what it stands for. But this is going to essentially print everything except the first element of a list. And these guys are very interesting because they allow you to do some interesting iterative logic with lists, as we'll see in a second. You can also construct lists by using the cons function, and this essentially is going to take a car and then take a CUDR, and it's going to append the two. So it takes the first element of a list, and then it adds the rest of the list right after. You can use this to prepend stuff to existing lists. So for example, if we take a look at this, this is the most basic usage. This returns the car of my list. So the first element, it's going to be A. Notice I get back A. If I print the remainder elements of the list, this is, excuse me, this is what I use the CUDR for. Execute this, everything except A, so I get B, C, and D. And I can also prepend stuff to the list. So in this case, I'm setting a variable called myList. So I'm essentially resetting this value, and it's going to be now the construction of thing before my list. So if I execute this, I get back thing followed by A, B, C, D, which is the old list we have. Now, what's interesting is that I can use CUDR in order to kind of iterate lists, as I was talking about. So essentially, I can make a while loop that iterates the elements of a list by repeatedly applying CUDR and then taking the car of the CUDR. What I mean by that is, if we open this, this function can print the elements of a list one after another. So I'm giving it a list as an argument, regular stuff, and I'm employing a while loop. So as long as there is an element on the list, I'm going to print the car of the list, so the first element, and then I'll set the list to be equal to its own CUDR. So I'm printing that first element, and then I'm removing it. And at each iteration, the list is getting smaller. And at one point, I'll have nothing left on the list, so I'll just leave the while, and I'll have printed everything just before then. Let's execute this just to show it off. So here I am defining a list which contains 1, 2, 3, 4, 5, and I'll print stuff on it. I'll apply the function to it. And let's actually take a look at the messages buffer. So this is where it is. So I printed all the elements of other lists. Now, by using these techniques, again with the while together with the CUDR and the car, I can actually grab the nth element of a list with a function such as this one. And there is a more direct way, but this is just a good way to show off what we've been looking at. So this function is going to print the nth element of a given list. I give it two arguments, a list and a number n. And while n is not equal to 0, what I'm going to do is I'm going to set the list to be equal to its own CUDR. So I'm going to remove the first element, and then I'm going to also decrement the number n. So whenever I reach the end coder of the list, I'm going to print its car because that's the car, that's the end element of the list. If I execute this, I get back the function, and then I'll apply this to this list. So A, B, C, D, E, F, 2, 3, 4, 5. I'll execute it, and if I print the end element of the list, in this case, n is equal to 0. So by regular programming, if you're used to arrays, this is actually the first element. If I run this, I get back A, B, C, and I can change this, for example, for a 2, and this should return the 2, which is the third element. And for example, 4 is going to return the 4, in this case, this element, which is the fifth element on the list. So if I set this to 1, again, I'm getting back G, E, F. And this is the long way to get the end element of a list. There is actually a quicker way, which relies on some shorthands. So one shorthand that I'll tell you is that you can set the car for a list, because in fact, car, the function itself, does not modify the list. It only returns the version, it only returns the car of the list. So the original list is not modified. But if you want to modify the original list, you can use the set car function. And this essentially does what it says it does. So it takes the list and then it puts a car in front of it. It constructs, it's going to construct a new list, and it's going to put a car on top of the old list. Set coder is similar, so it's going to set the coder of the list, it takes its car, and it prepends with a new coder. Finally, you have the end coder, which is what you can use in order to get the end element of a list, because again, the car of the end coder, so if I take this subset of the list and then I take its first element, this is actually the end element of the list. Which means that we can simplify our previous function with something like this, which is just what I said. So if I redefine my function, this is actually taking the car of the end coder of the list, which is essentially a shorthand for all of this while loop. If I execute this, it has to return the same thing. So in this case, print the end element of other list. If n is equal to 2, again, I'm getting back 2, which is this number here. If I use 0, I'm getting back ABC because it's the first element. Now to close it off, you actually have a do list, which is going to iterate the elements of a list. So it looks something like this. So do list, and then you assign it to a symbol and iterate over a list. So this symbol is the iterator again. So at each step of your iteration, the value of the symbol is going to be equal to the end element of the list. So I can use something like this in order to print all the elements of my list. I'll just input that. And I can apply this to other list. And notice here on the right that we get A, B, C, D, E, F, 2, 3, 4, 5. So the elements of the list. And that's it for this time, guys. Hope you guys enjoyed it. And I'll see you next time. Bye-bye.